Hi, I'm Bob Berdosi with Fillauer TRS. You'll remember TRS, it's easy to remember, the right stuff. So today I'd like to talk to you about how we can improve performance in a body-powered prosthesis. And I'd like to focus mostly on what would be transradial instance, the transradial absence. Typically you learned how do you control a prosthesis. I'm wearing a voluntary closing grip 5. So you had the control motions of glenohumeral flexion and bilateral scapular abduction. Those were the two primary things, forces or biomechanics that you learned to activate and create excursion in a body-powered prosthesis. What I'd like to emphasize today is that we're actually missing almost 30% of the biomechanics available to us that we have available. And it all has to do with the elbow. And what we want to do is, besides glenohumeral flexion and besides bilateral scapular or unilateral scapular abduction to create excursion, we want to be able to build in elbow flexion biomechanics. And it's a really easy thing to do, and it's a thing that many people just ignore or just are not aware of. And it's important to do it, and for many people it's going to improve their performance significantly. So you can see this prosthesis that I have here. This arm itself was built for me by Dave Rutter Prosthetics out of Illinois. It uses BOA control, uses a Sherlock technology, but it's designed to align the cable so that the cable goes behind the fulcrum of the elbow, so that when I come into forearm flexion or elbow flexion, this ELF strap, this ELF strap, which you're aware of, it's a crossbar strap, high-performance crossbar strap, captures that elbow flexion motion because there's a lever created between the center of my elbow, a fulcrum here, and the brim of the prosthesis. And the way the cable is routed, that allows me to simply just flex my elbow, and I get full closure of the terminal device. Whether you have a self-suspending prosthesis or not, makes a little difference. If you're using a prosthesis that uses a triceps cuff, then what we recommend is use a crossbar strap like the ELF strap. Do not attach the cable housing to the triceps cuff. Run your cable housing and align it just like this. Do not attach it to the triceps cuff. Let the suspension of the figure 8 harness just suspend the prosthesis and allow the cable housing and alignment and the cable to run from here, as you see it here, straight to the hanger for excursion control. So how else can we improve body power? Well, one of the ways to consider doing it is to throw away your Dacron web that you've been using for years and consider using polypropylene webbing. This is the type of webbing that is used in most sports equipment packs and things like that. It's softer, it's more flexible, doesn't have a hard edge, it washes and wears very well, and it's far more comfortable than regular Dacron type tape webbing. Also consider a different type of Axilla material. We call this Axilla loop padding. And Axilla loop padding is simply a section with the padding that you cut to shape, you cut to length, and it actually adheres to the outside of the Axilla strap using Velcro. So you stitch Velcro to the outside of the strap where you want this padding to be, and then it simply wraps around and butt seam. So it creates a washable, comfortable, low profile, I'm wearing it right now, low profile pad that your patients will love. This is a traditional modified Northwestern figure 9 harness. Has a loop, adjustable loop for the Axilla, typically used a steel ring. I've added into it a rapid adjust buckle, and then it's got a control strap. This works pretty well. I've used a design like this for many years. So what have we done for you to improve this? Well, we now have the BAHA 9. What is this? This is a high performance replacement for the steel ring. Why? Because the steel rings trigger off alarms when you go through the airport. We're trying to eliminate as much metal off the harness that we can, not only for comfort, but for all of the things we have to deal with in the 21st century. So not only do we allow for harness attachment, but we have incorporated a 4-bar buckle design right into the ring. So you don't need to have a ring and a 4-bar buckle to attach the control strap. It's all in one piece. So it's more compact, it's more comfortable, and it's lighter. And we've provided a system so that you have a lot of movement of the control strap and movement, again, and that allows for just improved biomechanics and better control over the body-powered harness system. This also incorporates a rapid adjust buckle. So we have the BAHA 9, that's our newest product. We have the original BAHA that was designed for figure 8 style harnesses, and the pediatric BAHA as well, which is designed for pediatric sized kids. If you're going to be building a body power harness, consider some of this new technology we have. Consider the polypropylene webbing, consider the Axilla loop padding for comfort, consider using the BAHA systems, whether it be the BAHA 9 or a BAHA 8 for figure 8 harnesses. This will give you just a nice high performance, comfortable, easily controlled, optimum operation harness for controlling body powered cables. I'm Bob Radosi. We'll see you next time.